Just going quickly over implied domain, we need to have a look at this because it does fall apart into the domain and range section. So the implied domain of a function is assumed to be the set of real numbers for which the function could be defined. So really, what you need to be careful with the implied domain is cases like a negative square root. If your answer is whatever it is, it's a negative square root. Or you've got, for example, 5 divided by 0. Okay, so there's two cases we need to be careful of: the divide by 0 and if you've got a negative square root. So when we're talking about implied domain, it doesn't differ so much from regular domain. We're still talking about the possible values of x that the function could be defined for. So let's look at this one here. F of x is equal to the square root of 3x minus 15. So this is actually the square root graph. But before we do this, let's do a couple of things. Let's x minus 5. So just so you know, this square root graph here, we can actually do a really quick sketch so that we've got an understanding of what it looks like. Okay, the end point for this graph will be at 5, 0. So the direction, there's no transformations for this one in terms of reflections. So this will be at 5, 0, and it'll be going in this particular direction. Okay, so let's look at this. What values do we have for x for this particular component here, the x minus 5, will this component be negative? So let's try at a couple of points. Let's try what would happen if it equals 5. Okay, if x equals 5, 5 minus 5 is 0. 0, this will become a square root of 0, which is, possible to calculate. If we have a really large number, so let's just say square root, so x equals 100. Okay, 100 minus 5 is equal to 95. This will be a positive number, which means it's still defined. But let's go on the other side. Let's try x is equal to 0. Okay. Now the reason why I chose 5 as well is because there was a 5 in this number here. If there was a 4, I would choose 4. I like to set this as my, I guess you could say, pivot point. Let's try x equals 0. 0 minus 5 is equal to negative 5. This will become a negative square root. And we said at the start, this is the one we have to be careful of. So the domain for this graph, or dom f, it can be anything to infinity, but the endpoint that we have to, I guess you could say, pivot around is 5. Now it can equal 5, okay, but anything less than 5 will result in a negative square root. So the next one, we have got a rectangular hyperbola for this case. So we need to make sure that we express it in that particular form as well. So this is going to be f of x is equal to 1 over 2 brackets x plus 10 on 4, which is 5 on 2. Okay, so this graph will look like this. It's got a translation of this here, and that's going to be asymptote. We don't really care about the coordinates as such at the moment. We just want to have a look at where the values are defined. Sorry, I forgot to finish off the previous question as well. The range of f. Okay, so the range, the possible values. It can be 0. It's defined for everything going upwards like that, but it's not defined for anything going downwards. So the range could be 0, and it goes all the way up to infinity, and it can equal 0. So going back to this rectangular hyperbola, okay, if we're talking about the domain, it can equal any number along this along the x-axis, except for this particular asymptote. So what we've actually got, the domain of f is all real numbers Okay, it can be all real numbers except for this particular point here, which is x is equal to negative 5 on 2. Okay. And the range for this graph, remember the range is y values. It can be any value along going up and down, but it cannot be this particular part here, which the asymptote is y is equal to 0. So, for this one, the range is all real numbers excluding 0. Okay. Now, this last one here is probably the trickiest one of all the examples. So let's look at how we can represent this. Remember the square root graph? We want to make sure we express it in its particular form. So we've got f of x is equal to 3 brackets. I'm going to take the negative out, and I've got negative x minus 7. Okay, and the plus 6 goes on the outside still. So if we draw a quick sketch of this graph, okay, the end point for this would be 7, 6. Okay, 7, 6. So 7, 6 would go up here. Now the question is, which way do we reflect this? Okay, so since there's a negative here, what happens is that it's reflected along, on the y-axis. So the square root graph will actually look like this. And this endpoint here is 7, 6. So let's talk about the domain and range. I need to stop doing that. Dom f. And the range. Okay, the possible values that it could be going from left to right. It can be any value from negative infinity. Okay, and it stops at 7. And it's a square brackets because it can be 7. And the range is from 6, and it can include 6, all the way upwards, so we can go up to infinity. And that's implied domain. Implied domain is pretty much just saying when you've got a particular function, say a square root or a truncus or a rectangular hyperbola, and there are restrictions, for example, negative square root or divide by 0, there's a domain that's implied with it. It's just an extra thing that we have to add on to domain.